Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
Right now, new and current customers can get any phone for free at US Cellular, so you can connect with all your family members this holiday season. You could even call your aunt, who always makes you talk to your cousin, who's a dog. Or, maybe just send her a festive text. Get the gift of connection at US Cellular. Get any phone free today. US Cellular, built for us. Terms apply. Visit uscellular.com for details.
We value human connection with fewer distractions. US Cellular, built for us. Visit your US Cellular authorized agent, Cellular Advantage, located at 918 South Locust Street in Glenwood.
This is SpaceTime Series 23, Episode 113, for broadcast on the 26th of October 2020. Coming up on SpaceTime, the new study showing Betelgeuse is closer and smaller than previously thought. 2 extreme bolts of lightning smashing all records for duration and distance. And the Dream Chaser spaceplane getting closer to its maiden flight. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown that the red supergiant star Betelgeuse is actually a lot closer and smaller than previously thought. The findings, reported in the Astrophysical Journal, will change science's understanding about the star, its history, and even its eventual death. The study's lead author, Meredith Joyce from the Australian National University, says the new observations suggest the star could survive for another 100,000 years before exploding as a core collapse supernova. Betelgeuse is the brightest star in the constellation of Orion the Hunter and the 9th brightest star in the night sky. This semi-regular variable red supergiant represents the scorpion's sting on Orion's shoulder or armpit. Although we're calling it Betelgeuse, it's also commonly known as Betelgeuse. Both are mispronunciations of the original Arabic name Betelgeuse, meaning the hand of the big man being Orion the Hunter. Betelgeuse has achieved a lot of notoriety of late because it's been behaving very strangely over the past year or so, after suddenly dramatically dropping in brightness for several months. That raised some serious concerns amongst astronomers that this red supergiant was now nearing the end of its life and was about to go supernova. And it's a legitimate concern. You see, Betelgeuse is estimated to be around 10 million years old. Now, that might only make it a youngster for a yellow dwarf star like our Sun, but for a star which started out as an OB blue star, 10 million years is a lifetime. And so once it's entered its red supergiant phase, it was legitimate to think that this star could be approaching its end of days, meaning it's about to go supernova any day now. Of course, in astronomical terms, any day now could mean tomorrow, or it could mean in a million years from now. However, by March, Betelgeuse began brightening again, thereby ending any speculation of an impending celestial spectacular. Now, as we reported previously on SpaceTime, further studies suggested the dimming could have been caused by huge amounts of gas being expelled by Betelgeuse, condensing into grains of dust and blocking out some of the light coming from the star. However, since then, a second dimming event's occurred. And observations by Joyce and colleagues suggest that this second event was likely due to the pulsations of the star itself. The authors used hydrodynamic and seismic modelling to learn more about the physics driving these pulsations and to try and get a clearer picture of exactly what phase of its life Betelgeuse is now in. Their analysis showed that pressure waves, essentially sound waves, were the cause of Betelgeuse's pulsations. They also confirmed the star is still burning helium in its core, which means it's nowhere near exploding, at least not yet. Joyce says that means it could be another 100,000 years before the explosion happens. Mind you, when it does go supernova, it'll temporarily outshine all the other stars in the galaxy, and it will be clearly visible in the daytime sky from Earth. The last star seen by humans to go supernova in our galaxy was Tycho's star back in 1572, and that was before the invention of the telescope. Calculations of Betelgeuse's mass range from slightly under 10 to a little over 20 times the mass of the Sun, with some 100,000 times the Sun's brightness. This new study has revealed how big Betelgeuse really is, establishing that it has some 750 times the radius of the Sun. The actual physical size of Betelgeuse had been somewhat of a mystery, with previous studies suggesting that were Betelgeuse placed where our Sun is in the centre of our solar system, its surface would extend out beyond the orbit of Jupiter. But these new results show that it's around a third smaller. Once they determined its actual size, the authors needed to then adjust its distance from the Earth, determining that instead of being 643 light-years away as previously thought, it's actually closer to around 530 light-years distant, about 25% closer than previously thought. Joyce says the good news is that even at that distance, Betelgeuse is still too far away from Earth for its eventual supernova to have any significant impact here.
Betelgeuse has been behaving quite strangely, especially since November of 2019. So an international group that was kind of put together by a visitor to the Australian National University where I'm based, Chiaki Kobayashi, she assembled this team of scientists in Japan to try and figure out why this dimming was taking place. And the final results of our paper don't do much to explain that dimming event. But along the way, with all of our modeling, we uncovered some large differences in the fundamental parameters determined for this star, which ended up translating to a smaller radius, which, because we can measure its physical size in the sky, must mean that it's closer as well. And then actually there have been other dimming events since the one in 2019. And our modeling turns out to explain those other events pretty well.
The work that's been done here, it really changes our understanding of the star.
So yeah, I would say the main way in which it changes our understanding is in how the star works, because there was no definitive description of what was causing some of its brightness variations before. And our research demonstrates that this is something called the kappa mechanism, which basically causes acoustic variations or sound waves, pressure waves in the outer envelope of the star. And so it was our results that were able to demonstrate that this was the cause of some of its variable behavior.
Two separate dimming cycles the star goes through.
We focus on two of the particular cycles in our result, but the event that caused the dimming in 2019 actually was not a variation or a cycle at all. It was a dust cloud moving in front of it.
The condensation of dust.
Some external cloud moving in front of the star was the cause of the first big dimming event.
How did we establish its new distance?
So there's sort of three measurements that go into measuring the distance of a star like this. The first is how big it appears in the sky. So this is its apparent size. And then there is its physical radius, which is what we determined with our model using these pulsation periods. And then when combining those two, you can determine an estimate for the distance to the star from our vantage point. So it was the physical radius that we were able to determine with really high precision, thanks to these seismic considerations that other groups had not used before.
The fact that the star is smaller than what was previously thought, does that change how long it's going to live for now? Or is it still so big it doesn't really matter?
Well, it's still all of the parameters are sort of interconnected, and it is still by far large enough to go supernova. But the fact that we find it to be smaller and thus closer does mean that it is younger than previously thought, which means it's not nearly as late in its burning lifetime. So our results suggest about 100,000 years until a supernova event, rather than previous estimates of about 10,000 years. So it's an order of magnitude increase. It
was never really going to be a threat to the Earth. Its rotational spin isn't in the right direction. It's still too far away to be anything more than a really bright object in the night and daytime sky.
Yeah, it would have been exciting for astronomers if it went supernova, in the near future, just because of our ability to study and learn more about supernovae. But Earth was never really in danger. I don't think we have too much to worry about as far as supernovae.
Tell me a little bit about your work.
By training, I'm a stellar evolutionist. So my entire research is on the study of how stars live and die. I did my PhD in stellar modeling. So a lot of the tools, mathematical tools that we used in this study are ones that I have contributed to or helped design. And my research basically just concerns how stars behave and what their life cycles are as a function of their birth mass.
So Betelgeuse is now fusing helium. Is it making lots of carbon and oxygen and things like that? Is that what it's doing at the moment?
Yeah, so when it's burning a particular element, in this case helium in its core, then it's fusing byproducts of that nuclear reaction, and then that forms ash, which is not active material. It's residual material.
It's making carbon through the triple alpha process.
Yes, yeah, as a consequence. The burning, yes, that's great.
It's yet to go through other phases too, where it will burn progressively heavier and heavier elements.
That's the expectation from our models. Yes, that's not something that we can observe directly, but based on our nuclear reactions that we implement in the models, these are our predictions for subsequent stages of evolution for stars of this mass.
Do these things happen quickly in quick succession, or are we talking millions of years for each, or a few years, or what? What's the sort of time frame?
Yeah, so actually nuclear burning timescales are quite interesting. They get exponentially shorter as the element that's fusing goes up on the periodic table. So for hydrogen burning, we're talking about billions of years. Typically for helium burning, we're down to millions or hundreds of thousands. And then by the time you get all the way up to iron burning in stars that are sufficiently massive, that actually takes place on the scale of seconds.
The technique you used, astroseismology, tell us about it.
So astroseismology is a method by which we use the brightness variations or radial velocity measurements to determine scales or timescales of variation for a star. And if we analyze these in very special ways, then they tell us about the interior structure of the star. And so in the case of Betelgeuse, analyzing its variations gave us a really important constraint on the structure of the star, which in turn enabled us to isolate the radius and isolate the most likely burning stage of the star in a way that had not been done before.
This is done how?
So in our case, it was photometry, which are just direct brightness measurements. And because Betelgeuse is so massively bright, there's actually a long longitudinal archive of visual data for the star that goes back more than 100 years. And by constructing these light curves, you can measure the periods by looking at the data. And then from that, you can extract the time scale of its variation.
Can you actually see different parts of the star as they're pulsating?
See different parts of the star.
Meaning, do you actually see patches that are getting darker and lighter as they're moving further away from the core or closer to the core?
So that's something that radial velocity measurements would be used to do. So you can actually detect red shifts or blue shifts of different parts of the star, which would tell you whether it's moving towards you or away from you.
Is there any more work you'd like to do with Betelgeuse?
So actually, I was in contact with one of the designers of one of the tools we use, this astroseismic program that we create the theoretical models that we then match against the actual astroseismic observations. And he suggested using, how quickly the variations change as an additional constraint that could maybe tell us even more about what's going on in Betelgeuse's interior. So that's an exciting next step that we're interested in taking.
So I've always called it Betelgeuse. You just called it Betelgeuse. What about Betelgeuse, the original name?
Oh, well, so I guess what astronomers would prefer to call it is Alpha Orionis because it is the brightest star in the Orion constellation. Being American, I call it Betelgeuse. I guess it depends where you're from.
Just don't say it 3 times.
Yeah, well, some people joked on Twitter that the reason why it's appeared closer is because everybody was talking about it so much.
That's Dr. Meredith Joyce from the Australian National University. And this is Space Time. I'm Stuart Gary. Still to come, 2 extreme bolts of lightning that have smashed all previous records for duration and distance. And Sierra Nevada's Dream Chaser spaceplane getting closer to its maiden flight. All that and more still to come on Space Time.
We can stop HIV, Iowa.
One key step, getting tested for HIV.
An estimated 14% of people in Iowa living with HIV don't know their status. The CDC recommends everyone get tested for HIV at least once in their lifetime, or more often when needed.
So testing is important.
Yes! Testing is the only way to know your status. It's the first step in getting additional HIV prevention services or HIV care.
Find out more at stophiviowa.org.
Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated number 1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
2 extreme bolts of lightning have smashed previous records for duration and distance. The World Meteorological Organization says a bolt of lightning which lit up the skies over Argentina back on March the 4th last year lasted for a record-setting 16.73 seconds. That's over twice as long as the previous record holder, a flash in the French Alps back in August 2012, which lasted 7.74 seconds. The new duration record follows another record set by lightning nearby the previous year. On October the 31st, 2018, a single bolt of lightning ignited across the sky, stretching some 709 kilometres from the Atlantic Ocean over parts of Brazil and into Argentina. That was also more than twice as long as the previous record holder, a flash in the skies above Oklahoma in 2007, which stretched across some 321 kilometres. The new mega flash records, reported in the journal Geophysical Research Letters, were verified using satellite images recorded by the GOES 16 and GOES 17 spacecraft. Previous assessments of lightning flash duration and extent had been collected by lightning mapping arrays using ground-based networks of antennas and GPS receivers. But the satellite data has the added advantage of allowing meteorologists to observe lightning extremes that were previously unseen or beyond the range of ground-based detectors. This is SpaceTime. Still to come, Sierra Nevada's Dream Chaser spaceplane getting closer to its maiden flight. And later in the science report, a new study warns that the Great Barrier Reef's coral population has decreased by more than 50% since the mid-1990s. All that and more coming up on SpaceTime. The Sierra Nevada Dream Chaser spaceplane has completed its wind tunnel testing as it moves ever closer to its planned first mission to the International Space Station, which is now less than a year away, currently slated for September 2021. Dream Chaser was originally designed to provide NASA with a new reusable crew transportation system, flying crew to and from the space station following the premature mothballing of NASA's Space Shuttle fleet in 2011. However, the 10-metre-long winged lifting body spacecraft lost out to the more conventional Boeing CST-100 Starliner and SpaceX Crew Dragon 2 capsules. Instead, Sierra Nevada were awarded a commercial resupply program contract to fly Dream Chaser on at least 6 missions, carrying cargo to and from the space station. Since 2012, NASA's commercial resupply program has been using SpaceX Dragon capsules launching on Falcon 9 rockets and Orbital Science's, now Northrop Grumman Cygnus cargo ships, launching on Antares rockets to supply the orbiting outpost. The first NASA mission for Dream Chaser, called Demo 1, will use the Dream Chaser spacecraft Tenacity, carrying 5,000 kilograms of supplies and equipment to the space station. Attached to the rear of Tenacity will be the Shooting Star expendable cargo module, which will carry an additional 4,500 kilograms of supplies. The 5-metre-long Shooting Star module is designed to operate autonomously when in orbit, using its own 6 thrusters and powered by 2 giant solar arrays, developing some 6 kilowatts of onboard electricity. Dream Chaser will launch vertically aboard United Launch Alliance's new Vulcan Centaur rocket. It'll fly off Launch Complex 41 at the Cape Canaveral Air Force Station in Florida, eventually docking with the space station's Harmony module. Tenacity will return to Earth from orbit, carrying up to 1,750 kilograms of cargo and equipment, gliding to a conventional runway landing on the Kennedy Space Center's former Space Shuttle landing strip. The idea of a gentler runway landing will allow Dream Chaser to return to Earth more delicate equipment and experiments, which could be damaged if brought back to Earth through a rougher high-G capsule splashdown. It's understood that Sierra Nevada has now built 2 cargo-configured Dream Chaser spacecraft. These will be capable of flying 30 missions to the space station over a 10-year lifespan. The Dream Chaser design goes back over 60 years, with its origins in the United States Air Force 1957 X-20 Dinosaur manned spacecraft, which, had it been built, would have been launched by a Titan III rocket. NASA then continued the development of the design in the 1960s and early 70s with a range of experimental lifting body spacecraft, including the Northrop M2, the Martin X-23 Prime, the Martin Marietta X-24, and the Northrop HL-10. Then, during the 1990s, NASA used the same basic design to develop the HL-20 experimental spaceplane. That would eventually evolve into the X-38 Emergency Crew Return Vehicle, which was designed to be transported to the space station in the payload bay of the Space Shuttle. It would then be docked to one of the spare ports on the orbiting outpost, where it would remain until needed as an emergency escape pod. However, US federal budget cuts in 2002 cancelled the project. Meanwhile, as we mentioned earlier this year on SpaceTime, the Pentagon is now looking at using the Shooting Star cargo module as the basis for an autonomous unmanned military space station, which would be used for research and development and for training and operational missions in low Earth orbit. Sierra Nevada will redesign a version of the module to include guidance, navigation and control systems for sustained free-flight operations. It'll host specialized payloads, undertake experimental testing, manufacturing and assembly in microgravity, and carry a range of logistics. Longer-term plans could see higher elliptical and geostationary Earth orbits for the military space station, as well as even more distant lunar orbits. This is SpaceTime.
The holidays start here at Baker's with a variety of options to celebrate traditions old and new. You could do a classic herb-roasted turkey or spice it up and make turkey tacos. Serve up a go-to shrimp cocktail or use Simple Truth wild-caught shrimp for your first Cajun risotto. Make creamy mac and cheese or a spinach artichoke fondue from our selection of Murray's cheese. No matter how you shop, Baker's has all the freshest ingredients to embrace all your holiday traditions. Baker's, fresh for everyone.
And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has confirmed that coral populations in Australia's Great Barrier Reef have declined by more than 50% since the mid-1990s. The findings, reported in the Journal of the Proceedings of the Royal Society B, looked at changes in the populations of the 2,300-kilometre-long reef's small, medium and large corals since 1995. The authors found the decline occurred in both shallow and deeper water reefs and across virtually all species, but especially in branching and table-shaped corals. Scientists found steeper deteriorations in coral colonies in the northern and central Great Barrier Reef after mass coral bleaching events in 2016 and 2017. And of course, the southern part of the reef was also exposed to record-breaking temperatures earlier this year. The authors say climate change is driving the increase in frequency of reef disturbances, such as marine heat waves. A new study warns that babies are consuming as much as 16 million microplastic particles in every litre of formula they drink. The polypropylene-based microplastics is coming from their feeding bottles. The findings, reported in the journal Nature, also showed that the high heats used to sterilise bottles significantly increased microplastic release. The study found that babies in Australia are likely to be exposed to around 2 to 3 million microplastic particles every day. That compares to around 600 microplastic particles per day for adults. The authors say there now needs to be an immediate focus to assess the potential risks of microplastics for human health and to develop products that aren't easily degradable by water or the environment. Scientists have set a new superconductivity temperature record, creating a material that conducts electricity without resistance at temperatures of up to around 15 degrees Celsius. However, the findings, reported in the journal Nature, show that the material needed to perform this phenomenon, a compound of hydrogen, carbon and sulfur, only survives in extreme high pressures, approaching those found at the centre of the Earth. Of course, that means that this material is unlikely to have any immediate practical applications, and of course it will also be very tricky to analyse. Well, it's something our parents knew and something their parents taught them. Now, scientists have confirmed that it seems letting kids play in nature in a little bit of dirt is good for their microbiome and immune system. The findings, reported in the journal Science Advances, are based on new Finnish research in which scientists spread forest foliage over the bare spaces in a number of daycare playgrounds where kids would spend about an hour and a half each day. After a month, researchers found that kids who had played in the dirt forest foliage had a better mix of beneficial microbiome on their skin compared to a control group that didn't get the green makeover. The authors say the new findings suggest that natural interventions could improve children's health and well-being. Australian skeptics have held their glittering annual conference Skepticon on the Gold Coast. Although things were a bit different this time thanks to the COVID-19 pandemic, the whole thing was held virtually. But as always, the highlight of the event was the annual Bent Spoon Award. And with the details of this year's winner, we're joined by Tim Mendham.
It was a virtual event, virtually exciting because we had to all be separate because of COVID.
You're all separate
so we didn't
together.
Yes, and of course during the convention we always make our announcements of our annual awards, and the least sought after award is the Bent Spoon Award, which is given out to the perpetrator of the most preposterous piece of paranormal piffle.
You've rehearsed that.
I have to take a deep breath before I do it. But yeah, we've been giving that for almost every year that the skeptics have been in existence, from the early 80s. I think we missed 1 year, which is rather disappointing that there were no candidates. But this year we had a bumper crop of candidates. We had a lot of good people who were nominated, and people in the public can nominate. So we had some old favourites who had actually already won, so they were going for a second run. One that someone recommended was basically the Murdoch press and their attitude towards COVID and masks and pandemics and climate change and a whole lot of basically anti-science stances. They were nominated. Meryl Dorey, who sometimes runs the Australian Vaccination Risks Network, and their Vaxxed bus, which is travelling around Queensland and New South Wales at the moment, and sort of trying to gather stories of people who have been damaged by vaccines. But they didn't win, despite their good efforts in trying to sort of claim the prize. The winner of the 2020 Bent Spoon Award was someone who has won before, Paleo Pete Evans.
Tell me what made him so deserving.
Paleo lately has been doing so much to be deserving. It's an embarrassment of riches. Obviously, in the past, he won it in the past for his anti-vaccination, anti-fluoride stance, and he won it in about 2015, I think it was. But this year, of course, was the biocharger, the machine that would treat thousands of different illnesses, including coronavirus, with basically just a few coloured tubes and a Tesla coil. Make it go zap, 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 and the light goes through colours, and that's supposed to cure you from all these awful diseases. And that was being sold for $15,000 each, and he got fined by the Therapeutic Goods Administration for $25,000. So if he sold two, he covered the fine. But Paleo Pete has been increasingly making strange statements. Obviously, the last year or so, it's been making claims that you can sort of help your eyes by getting some vitamin D by staring at the sun, which people say no. He continues his anti-vaccination stance. He recently had Andrew Wakefield, the famous proponent of the autism stroke vaccination theory.
Which has been totally discredited.
Absolutely, totally discredited. There's no foundation to it. There was really no foundation when he was putting it forward either.
It was a fraudulent scientific paper that he submitted.
Totally, and the paper was withdrawn and he was thrown out of the British medical fraternity because of it. But
no longer a doctor because he did it.
No longer a doctor, but he's still a martyr to the cause, apparently, and therefore Paleo Pete had him on his podcast. Always with the Bent Spoon, we ask around all the sceptical groups in Australia. We're very democratic, and everyone said, yep. Pete has said, he has won before, but when you're deserving, and he's actually the first person ever to win the Bent Spoon twice.
What happened to him last time he won the award? Was he very honoured by the whole thing?
I wouldn't say honoured. No one is particularly honoured to win it. They tend to be dismissive of the skeptics, say they don't understand. Others went to town on it, and that was good. And the Chaser had a little article in one of their 6 times a year quarterly publication, A Day in the Life of Pete, where he was going off to the awards ceremony, putting on his tuxedo to get the Bent Spoon, assuming it was a culinary award. Because it's a spoon. It is a spoon. We actually have the award.
And we thank Uri Geller for his efforts there too.
Yes, it's mounted on gopher wood from Noah's Ark, and it's a bent spoon on top, obviously bent by Uri Geller from a distance. And it's now firmly secured to each other. It did have a tendency to fall off occasionally. But not anymore. And secured to the gopher wood by a Phillips head screw from the One True Cross. And it has all the names of the winners. And every few years we have to add another layer of gopher wood, which is getting increasingly hard to find.
I feel sorry for all the poor gophers.
Yes. So there's a lot of history in that on the little plaques around the rim of the award. It actually show the way that pseudoscience and the paranormal have developed in Australia in that time, and certainly how the skeptical movement. The early ones are ghost hunters and psychic dentists and all sorts of strange paranormal claims. Now they tend to be on the pseudoscience area, the anti-vaxxers, the people who are actually more dangerous than the original winners were. The original winners were amusing, a bit silly, but the most recent winners tend to be people espousing, promoting misinformation, which can be dangerous.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.